Okay, it's got a light inextensible string of length 0.8, and we got string particle of mass mg. So we got mg there, we got tension going up there, and it's given a velocity, a horizontal velocity of 0.3 meters per second. Okay, and show that in a subsequent motion, the maximum angle between things is 0.107 radians. So we're there, and that's gone through. So that's like so. That's theta. That's what I've got to find, and I need some. It's going to be an energy question, the first part. So to I down here. So I'm going to have total initial energy equals to total final energy, and it's going to be made up of two parts each side, because I've got the mgh, gravitational potential energy, and I've got a half mv squared. I'm going to write that down both sides just to remember in case I forget one part of it. So I'm going to take the initial thing, baseline to be there, so it's going to be 0 plus half times the m times by v squared, so that's 0.3 squared, so times 0.3 squared, and that's going to equal my mgh, so it'll be mg times by h, and the height that's 0.8, and the height is this bit here, is how much extra it's gone, so that will be mg 0.8 minus this bit here, which would be 0.8 cos theta. So 0.8 cos theta plus the final kinetic energy when it stops there is obviously going to be 0. And now we can tidy this up a little bit, divide through by m, and this will give us 0.045 equals 7.84 minus 7.84 cos theta. And so cos theta equals 7.84, so 7.795 over 7.84, which equals 0.99426. So 9 there. And so theta equals 0.107194 radians. Okay, so 1.07 to 3 significant figures. Got a lot of working for that first bit. Show that the model may be modelled as a simple harmonic motion. So for this bit, normally I get x double dot equals minus n squared x, but here we're going to have to show that theta double dot is approximately equal to minus n squared theta. So that's what we're going to try and do. So let's put some forces onto here. I've got, at this stage here, I've got mg going straight down, and I've got the tension going up there. And let's put the various bits I know. I'll do in purple. I've got a component of the acceleration going inwards. That'll be a equals, I can have v squared over r, or r omega squared. And I'm also going to have an acceleration going this way, tangential one, the acceleration. Well, I know that v equals r omega, so a will equal dv by dt, which equals d r omega by dt, which will equal r omega dot, or r theta double dot. So that means I'm going to have to resolve tangentially. So I'm going to have to resolve tangentially, and I'm going to go that direction, and I'm going to get resultant force equals mass times acceleration, and the resultant force is just got, I do it in my normal pink, let's split that force up into that bit, it's just this bit here, which would be mg and it will be sine theta. But I'm taking that to be positive, so this will be negative. And the reason I'm doing it that way is because I normally think of my theta as having a turn that way, so that's my positive. So that will give me minus mg sine theta equals mass times by r theta double dot, and r is 0.8 theta double dot, and that says that theta double dot, get rid of that, equals minus 12.25 sine theta, and for small theta, sine theta approximately equals theta. Therefore, theta double dot equals minus 12.25 theta, and that's shown it, and that is n squared. So n equals the square root of 12.25, which is 3.5, which is good. And find the period of these things. So the period, whenever we write period, we always write down 2 pi over n, which equals 2 pi over 3.5, which equals 1.795196 seconds. So that's done part 2, and now I need to do part 3. So part 3, we've got find the time after the start of the motion when the velocity is first of v equals minus 0.2, and find the angular displacement. So I need to find theta from the downward vertical at this time. So well, that's quite a useful thing to do. Normally, again, we get x equals a sine nt or a cos nt, and this is sent from the center, so it's going to be theta equals a sine nt, and so theta equals a. Well, now it has to be in terms of radians, so that will be our 0.107194. So 0.107194 sine, and we've got n we worked out was 3.5 t, and we want to know about velocity, so we're going to have to differentiate this to get theta dot is, that means times by that, so it'll give us 3.5 times by 0.107 is 0.375179. Differentiate sine, we get cos 3.5 t. But that's theta dot, and we need to know what theta dot is. Now we know that v equals r omega, and the velocity is minus 0.2 equals 0.8 omega, and therefore omega equals minus 0.2 over 0.8, so omega equals minus 0.25, and that's what we've got. We've got omega is of course theta dot, and we've got theta dot here, so therefore we have 0.375179 cos 3.5 t equals minus 0.25, and therefore cos 3.5 t equals minus 0.66638486, and so 3.5 t equals 2.30097, so t equals 0.65717 seconds. So I found the time, and now I need to find theta, and so I get, using my general formula, theta from here, theta equals 0.107194 sine of 3.5 times by t, which is 0.65717, and so theta equals 0.079928 radians. And a bit squished again, but that's question 7 and the whole paper done.